Okay, so now I'm recording. Yeah, I'm recording already. Okay, so 1.3 electric potential. Okay, so what is actually electric potential? So let us look at the notes first. Yeah, electric potential symbol is V. Is defined as the work done by external force per unit charge to bring a test charge, a positive charge, from infinity to a point in an electric field produced by a source point charge. Like you see here, there's point charge. I want to bring a test charge from infinity to a certain point, nearer to the point charge. I need to do some work. Yeah. So that work done divided by the test charge, I get the electric potential at that point. Okay, so this one needs some explanation. Yeah. So most probably you don't understand what it's talking about. Okay. Where Q naught is test charge must include the sign. Okay, all these later on. Okay. So let me explain about this. Yeah. So okay. So let's take it this way. So electric. What we were talking about electric potential. Okay. So we are in 1.3 electric potential. Yeah, electric potential. Okay, so this symbol is V. Okay, electric potential V. So okay, now imagine you have a point charge. Okay, point charge positive Q. I just put as positive Q. This one is what we call the point charge. Okay. Okay, point charge. What's the function of point charge? What's the function of point charge? It provide the electric field. It provide the it provide the electric field around it. Right? Correct, not class? It provide the electric field. Yeah, around the point charge. Ada electric field lah. Understand? Okay. So electric potential. Yeah, electric potential. So what does it mean? Okay, so around this is a point charge. Around the point charge, you have electric field. Yeah, so electric field is a region where you can feel the electric force. If you put another charge inside the electric field, you will feel the force, isn't it? The electric force, either attractive force or repulsive force. So that's electric field. Okay, so when you have electric field, yeah, you have a region of electric field, they also have electric potential at every point in the electric field. Yeah, so normally how do we draw the electric potential line? So let's look at the notes. I want to show you. This is how we draw the potential line. Yeah, we call it equipotential lines or surfaces. Equipotential lines or surfaces. So this is how we draw. Yeah. So later I will explain one by one what does it mean by this equipotential line, yeah, and so on. Yeah, so just bear with me. So you have equipotential line, so let's draw it. Yeah, so like that. Okay, so okay, maybe I need for so equipotential line. Yeah, at first it's nearer to each other. The line is nearer to each other. But when further away, it get further apart. Further apart. And then when going further away, make it longer. Yeah, I need to make it longer. Yeah, not enough. Yeah. Okay. So you can see further apart. Yeah, like that. Let's make it smaller first. Easier to draw. Like that. Yeah. Okay, then we can make it bigger. Yeah, that's it. Yeah. So, okay. Now, you know, potential, like potential energy. Yeah, the word potential is like potential energy. Okay. So we can feel that in this electric field. Yeah, maybe you should draw electric field. Electric field. So in this electric field, there are, you can feel, if you have another charge inside the electric field, you will feel the electric force, repulsive force of attractive force. Okay, and they have different level of energy. Different level of energy. So I put it this way. When further apart, yeah, like I put this here, you have 4 points. I put as 4 points. Okay, 4 points. So I put it, this is point A. At point A, the potential is 100 volt, something like this, 100 volt. And then nearer, when going nearer point B, yeah, how should I write? Not enough space actually. Potential at B is 200 volt. 200 volt. Nearer, you have here point C. This one is 300 volt. Okay, and then point D. Point D. This one, yeah. This one is point C, and this one is point D. Point D is we put it as 400 volt. 400 volt. Can you see, class? Can you see? Give me a thumbs up if you can see what I'm drawing. Can you see? Can you see clearly? Yeah. Hopefully you can see. Yeah. So sorry because yeah. Hopefully you can see it. Yeah. Yeah. Okay. So maybe I should write another place. Yeah. This is 100 volt. This is 200 volt. Maybe you should wait, let me use other color. Yeah, this is 100 volt, this is 200 volt, 300 volt, 400 volt, this way. Yeah, this is what we call equipotential line. Yeah, this one is what we call equipotential lines, or surface. Why we say surface? Yeah, lines is 2D lah, 2D. Yeah, 2D in a circle. Yeah, so it become a circle, right? Yeah, but in actual, charge is actually like a sphere. So equipotential surface is actually in a sphere. Yeah, 3 dimension. Yeah, so that's why we say surface. It's a sphere actually. Yeah, exists in a sphere. So equipotential, that means equi means same potential. Okay, understand? So along this line, let's say the outermost circle, they all have the same potential, 100 volt. 100 volt. And then the second surface, this one is 200 volt all around. You understand? Outside one is 100 volt all around. 100 volt, 100 volt. Equipotential. Equipotential. And then for the second surface is all 200 volt. 200 volt, 200 volt all around. And then the third surface is 300 volt, and then the fourth surface is 400 volt all along. So that's why we call this line a equipotential line. Understand? Okay, now the question is, what does it mean by this V potential 100 volt? The 100 volt itself, what does it mean? The 100 volt itself, what does it mean? What does it mean? 100 volt. What? Apalah maksud 100 volt kepada kamu? That is the question, isn't it, class? Isn't it, class? I want to see your response. Is that your question? What is the meaning of 100 volt over here? Yeah. So that's what I'm going to explain. Yeah. What is mean by 100 volt over here? What is mean by electric potential? Okay, so looking at the notes, potential is work done per charge lah. See, work done to bring blah 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 blah. Work done per unit charge. That means work done per charge. Okay, begini. So 100 volt. Okay, so I put it this way. Potential VA is 100 volt. What does it mean? Okay, what's the formula for potential? Work done over test charge, isn't it, class? So 100 volt, yeah, just now you see work done per unit test charge. So 100 volt it means you use 100 joule of work to bring a positive 1 coulomb from infinity to that point. That's it. That's what it means, class. That's what it means. Things that are important, big it in bracket. Okay, so what does it mean by 100 volt over here? That means if let's say I have a positive 1 coulomb at very far away. Why it must be very far away, class? Why it must be from very far away? Very far away. It must be from very far away from, r equal to infinity. R equal to infinity, that means from here go to here, the r is infinity. It means like this. Okay, so just one, okay, don't write. So just put this as r equal to infinity lah. At very far away, where at infinity, okay, when this is what we call test charge. This is what we call test charge Q naught. This is the Q naught. Q naught 1 coulomb. So when this test charge is at very far away, so at very far away, there's no the repulsive force is equal to, because we know positive charge and positive charge. Here there is 1 point charge over here, and then here it has a test charge. So you have 2 charges here, right? 2 charges means they positive, they repel, isn't it? They repel. But R infinity, that means they are very far away from the charge. So the electric field at this point is very low, very weak. So that almost at this point, at infinity, the electric force is almost near to zero. Understand not? Like near to zero. Like no repulsive force. So free from influence from the other charge. This test charge is like not rarely repelled by this point charge. Okay, so like this test charge is very free over here. But now if you want to bring this test charge nearer to point A, this is a point A lah, yeah? This is point A. If I want to bring this test charge from infinity to that point A, I want to bring this test charge nearer. I want to bring it nearer. Positive 1 coulomb. I want to bring it nearer to this point, positive 1 coulomb. So do you think this test charge can move by itself to that point? Do you think this test charge can move by itself? Bolehkah dia bergerak sendiri ke point sana, point A, class? I want to see your response. Can this test charge 1 coulomb can move by itself to point A? Can or not? Any response? Yeah, you must remember, positive, they always repel each other, isn't it, class? Repel. So, bolehkah test charge ini dia bergerak sendiri ke point A? Bolehkah? Bolehkah, class? Ya, bolehkah? Thumbs up itu maksudnya apa? Boleh bergerak sendiri?
Tidak.
Macam mana dia bergerak sendiri ya, kelas? Bolehkah dia bergerak sendiri? Kalau benda ini sudah kena repel, bolehkah test charge ini bergerak sendiri ke sana? Bolehkah?
Tidak.
Tak boleh, ya. Sebaliknya dia akan menjauhi dia sejauh-jauh yang mungkin, betul tak? Ya, if can is being repelled by the point charge, so this test charge should go as far away as possible. Go to infinity, isn't it, class? It cannot move by itself to there. So how will this charge? How do you move this charge to that point, to the point A? That's why you need to have external force. You are the one who going to bring this test charge from this point to that point. Understand? If got external force, you want to bring this test charge from this point to this point, that means this external force come from you, isn't it? That means you need to do some work. There is some work done involved. So how much work done do you think, class, to bring this test charge of 1 coulomb from infinity to point A? How much work done is used? 100 volt. How much work done is used, class? How much work done is used? To bring a test charge from infinity to point A, how much work done is used? Since it cannot move by itself, this test charge is being repelled by the point charge. So of course, you are the one who need to do the work to bring this test charge from infinity to that point. It cannot move by itself. You are the one who going to push it to that point A. How much work done is used, class? How much work done is used?
100.
Sorry, I cannot hear you.
100 joule.
100 joule, that's right. So you need to do, if potential over here is 100 volt, that means to bring a positive 1 coulomb of test charge from infinity to point A, the work done involved is 100 joule. That's what it means by 100 volt. So 100 volt, it means the work done to bring a 1 coulomb, positive 1 coulomb from infinity to that point in the electric field. Understand? At infinity is almost like no electric field. But if you want to bring this test charge to a certain point at the inside the electric field, so you must do some work. Okay, it cannot move by itself. Understand? Now, how about bringing the test charge from infinity to point B, 200 volt? What do you think? How much work done is used to bring a positive 1 coulomb from infinity to point B? How much work done is used? Do you think it need to do more work or less work compared to A? Compared to A. More work, isn't it, class? You want to bring this test charge from very far away, from infinity to point B. That means now much nearer to the point charge. Much nearer to the point charge. More difficult or more easy? To point B. More difficult or more easy to bring the test charge from infinity to point B compared to point A?
Difficult.
More difficult, that's right. So to bring to point B, so how much work done is used? How much work done? 200 joule, that's right. What about bring it much nearer to point D, let's say point D. Bring from infinity to point D. How much work done is used, class? 400 joule. That's right. So what is mean by potential of 400 volt at point D? What does it mean? What does it mean by potential of 400 volt at point D? It means that the amount of work done for positive 1 coulomb, the work done used to bring a positive 1 coulomb from very far away, infinity distance, to that point in the electric field. Understand? If higher potential means you need to do more work, If lower potential, you mean you need to do less work. Understand, class? I don't know lah your response because I cannot hear. Just now you got thumbs up. At least I can see. But because I only have one screen, I don't know you thumbs up to me. Yeah, thank you lah for thumbs up, but I didn't see. Thank you for very much. Now, class. Okay, let's say now instead of one column, now I want to bring positive 10 column. Positive 10 column. Make it even weirder. Maybe I want to bring this time. I want to bring positive 30 column. Positive 30 column test charge. To bring it from infinity to, let's say, point B. To point B. Okay, to point B. So point B is potential 200 volt. So now I want you to calculate how much work done is used. Berapa work done? What do you think? How to do that? How?
6,000.
Yes, that's right. 30 multiply the potential. So you see, V is equal to W over Q naught, isn't it, class? So we can cross multiply. That means W is actually Q naught multiply V. Correct or not, class? W equal to Q naught multiply V. So that means 30 kolom multiply potentialnya 200. So berapa? You need to do 6,000 joule of work lah. 6,000 joule of work. So that means 6,000 joule of work done. So to bring a positive 1 column, potential 200 volt means the 200 volt is 200 joule for 1 column. 200 joule for 1 column. Yeah, 200 joule for 1 column. So if 30 column, then you need to multiply lah to 200 with 30. So you get 6,000 joule. So bigger charge, even more difficult. You need to do more work. You need to do more work to bring a bigger charge nearer. Understand or not? You need to do a bigger work to bring a bigger charge nearer. Because why? Even more repulsive force. Bigger charge means it faces higher electrostatic force, higher repulsive force. So you need to do more work. That's the concept, class. That's the concept. I'm teaching you the concept. Okay, class? Understand? Yeah. So half an hour already. Yeah. So okay. Let's continue. That's just the just the theory. Okay. Okay. So now okay. Now you understand, potential is work done per unit charge. Per unit charge means, okay, let me write like this, yeah. So so this is what it means. Okay. So potential is work done, amount of work done lah. Yeah, amount of work done. So okay, work done. So per unit positive test charge. Per unit positive test charge means positive 1 column lah. Yeah, work done for 1 column per unit. Per unit means 1. Per unit means 1. It must be positive test charge. Okay, it must be positive test charge. Okay, per unit charge to bring a test charge from infinity to a certain point in the electric field. Okay, this electric field is produced by the point charge. That is what it means lah. Okay, you understand the definition now? Hopefully you understand. Yeah. Now I want to now the equations. I want to explain here why he say the test charge you must include the sign. Why the test charge you must include the sign. And then the point charge also must include the sign. What does it mean? Okay. Last time you learn what? You learn force and electric field, right? You learn force and electric field. Where is it? You learn force and electric field. You see, if force, the sign of charge can be ignored. The sign of charge can be ignored. But now, okay, the electric field also be mentioned about. Never mind. But now potential. The potential. Talking about potential, you must include the sign. Point charge also must include the sign. Why? What the difference? Why there's a difference? Okay, let me summarize this one. Yeah, let me summarize this one. Okay, so what have you learned? What have you learned? You have learned about electrostatic force, or we just say as electric force. Same, yeah? Electrostatic force is electric force. Fe. The formula is KQQ over R square. And then you learn about electric field strength. You learn about electric field strength. And then this one is E, okay, equal to what? Force over Q naught. Yeah, become KQ over R square. Okay, KQ over R square. So you learn that okay, force, it involve point charge, it got test charge, consider both charge. But for electric field, it is only the point charge, kan? Only the point charge provide the electric field, yeah? The point charge provide the electric field, and we divide by test charge, kan? We divide by test charge. Okay, class. These two, they are vector. Yeah, I'm saying about this. The force and electric field, both are vector. Okay, both are vector. Vector means they have magnitude and also direction. Correct, right? Correct, class? Okay, so they have magnitude and direction. So when finding the magnitude of force, resultant force or resultant electric field strength, when finding the magnitude, when we use this equation KQQ over R square, or we use KQ over R square. So when finding the magnitude of a vector, the charge, we ignore negative sign. Understand? The charge, we ignore. Put it okay, let me wait. The charge, ignore. Ignore, the word ignore, yeah? Negative sign. Understand? Because why? Because we just want the value. Yeah, we just want the value. Yeah, value is important. We don't want the negative sign from the charge to disturb our value. Okay. When will we use the positive negative sign? Only in direction, determining the direction. Or what we can say, when we doing the, want to find the resultant force, resultant field strength, direction to the right, positive, direction to the left, negative. That one, that is what I means. Yeah, we use for that one. We use the positive negative sign to represent the positive x component or negative x component, positive y component or negative y component. That one, yeah, this one. Because when we find the resultant force or resultant field strength, there are components to the right, there are components to the left. Components to the left, that one we must put negative component. Components going up is positive, components going down must be negative. So that one we must consider the negative component, must substitute the negative sign. Understand? When doing the xy component. That one must substitute positive negative sign. Okay, but when finding the magnitude only, we ignore the negative sign for the charge. Okay, now talking about this, the later on, we talk about potential. Potential. So now we learn about electric potential. Yeah, electric potential. V. V. What is the electric potential? What is the formula? Yeah, what is the formula? Okay, we know that it is KQ over R, isn't it? Or we can say work done over test charge. Work done over test charge. Or KQ over R. If you can see the formula over here. Work done over test charge or KQ over R. No R square. You see that? For vector like force and field strength, you have R square. See that? You have R square. But for potential, only R, no square. No square. Okay. Also the dia macam electric field strength divide by test charge, and then here is point charge. Point charge provide the potential. Point charge provide the electric field. Point charge provide the potential. Kan? Isn't it? See that? This electric field line provided by point charge. This potential line 100 volt, 200 volt, all also provided by point charge. That's why electric field strength guna KQ, point charge. And then potential pun guna KQ, point charge juga. Understand? Because it's the point charge provide the potential. Understand, class? Divide by test charge. Divide by test charge. Okay. Hopefully you remember this one. Okay, class. Now, for potential, it is a scalar quantity. Why scalar? Because we know work done. Work done is a scalar quantity. Work done is a scalar quantity. Energy, kan? Energy is a scalar quantity. No direction. So potential also a scalar quantity. So scalar quantity only has magnitude. No direction. Only has magnitude. Understand? Only has magnitude. For this case, the charge cannot ignore the negative sign. Must include the negative sign. Why like this, class? Why? Okay? Why? Okay. Like this. Yeah? Why like this, class? Why the charge must include negative sign? Because how to say, okay, you say that charge must include negative sign. So in what sense, in what situation you say you must include negative sign? It means that if let's say if given the charge is negative 100 coulomb, yeah, if Q is negative 100 coulomb, and when we want to find the potential, the magnitude, we want to find the magnitude of potential V, we use formula, what formula do we use? We use KQ over R, isn't it? This Q, you must substitute the negative. We must substitute the negative. Okay? Negative. The negative sign, mass, is a mass. Is mass. Okay? But, class, if the same questions, he asked to find electric field, let's say. The same question asked to find, let's say I want to find electric field. If I give a charge of negative 100 coulomb, asked to find electric field. Electric field equation is, let's say, E equal to KQ over R squared. This one, we ignore the negative sign. Just put as 100 coulomb class. 100 R squared, 100. So we ignore this one. Oh, we ignore the, sorry, excuse me, for 1 second. Okay, so, oops, 1 second, 3, I'm start recording again. Now, so this one, the charge ignore the negative sign. Okay. This is what I mean. If asked to find electric field strength, the charge we ignore negative sign. But let's say if want to find electric potential, which is a scalar quantity, the charge, if you have negative sign, you must have negative sign, must include. Okay. Okay. Why like that? Why like that? The question is why? Why this charge ignore negative sign? This charge must include negative sign, class. Okay, as simple as that. Since you asked why, you actually didn't ask anything. Yeah, you are just quiet. You are just quiet. But I'm sure that you have the question. You surely have this question before you knew you knew it. Yeah, I sure you have this question before you knew you have these questions. This is what I mean. Yeah. Okay. Why this case the charge ignore negative sign? This one the charge must include negative sign. Good. Like this. Yeah. Okay. If I give you E equal to negative 10, don't put 10 lah. 10 is too common. Negative 50 Newton per coulomb. What does it mean, class? Compare to V equal to negative 50 volt. What does it mean, class? What does it mean by the negative sign here and the negative sign here? Does it mean the same thing, class? Does it mean the same thing? Does it mean the same thing, class? Even so, I give another example. The force, same thing. Force equal to negative 50 Newton. This one. What does it mean by negative 50 Newton? What does it mean by negative 50 Newton per coulomb? What does it mean by negative 50 volt? What does it mean, class? Can somebody tell me? Can somebody tell me? You cannot answer me because you have these questions. Because you have this question. That's why you cannot answer me. Okay? So it's always I ask, I answer. It's never you ask, I answer. You are always quiet. That's one thing I noticed. Yeah, you are always quiet. And it's always me ask and me answer. Okay? Okay. Let me answer. It's okay. Okay, negative 50 Newton. Okay, if I have electric force negative 50 Newton, it can means that the force is 50 Newton to the left. To the left. Understand? 50 Newton to the left. Because it's a vector, understand? 50 Newton to the left. Okay? Why we say 50 Newton to the left? Maybe I have a negative charge over here, negative Q, and here has a positive charge. So the force acting on this positive charge is 50 Newton to the left. This is what it means by negative 50. Understand? Vector, vector, vector. What does it mean by negative 50 Newton per coulomb, class? What does it mean? It means that it is the electric field is 50 Newton per coulomb to the left or downwards. Yeah, anything you like. Yeah, 50 Newton per coulomb to the left. That means what? That means let's say I have a negative charge over here at point P. It has 50. The electric field is towards the negative charge, isn't it? Towards the negative charge. So at point P, the electric field is 50 Newton per coulomb to the left. Electric field is 50 Newton per coulomb, arrow to the left. Yeah, towards the negative charge. Understand? This is what I mean by negative 50 Newton and negative 50 Newton per coulomb for force and electric field. Understand? Now, what is negative 50 volt? So you see, class, that's why for to find the magnitude, we always jangan nak kacau the we don't want to disturb the magnitude of electric field. So we always maintain the charge as positive value. So to find this, let's say like 15 Newton or 15 Newton per coulomb, we just want the positive value. We want the positive value. We only put the negative. We only put the negative sign for direction to the left. Set direction to the left. Then we put the negative sign. But when finding the value of electric field, let's say the charge, we ignore the negative sign. But class, negative 50 volt, what does it mean? What does it mean, class? Is it mean, I have a, is it mean that, I have a negative Q over here? Let's say a point P, the potential, let's say the potential P over here is negative 50 volt. Negative 50 volt. Is it mean, if the potential is 50 volt to the left? Is it mean that potential over here is 50 volt to the left? Adakah dia bermaksud 50 volt to the left? The negative sign over here, is it mean 50 volt to the left? Yeah? Potential, is it mean, is it a vector quantity, class? Is it a vector quantity? Huh? Can someone answer me? No, it's not a vector. So is it mean a scalar quantity? Scalar quantity with negative 50. Is it mean 50 volt to the left?
No.
No lah. Yeah. Why it take so long to answer me? You should immediately answer me. Yeah. Okay. I'm making a joke here. So okay, at least you. Okay, never mind. Okay. The more I say, is wasting time only. So 50 volt. This is a joke lah. This is a joke. It's not 50 volt to the left. Okay. You will see something like this, class. I'll tell you. You will see something like this. I'll tell you. Yeah, I tell you first. You will see something like this. If you have a positive charge over here, let's say I put it as a positive or positive charge. Okay. So we know the electric potential. Okay, you will see something like this. I tell you first, class. I tell you first. I always tell my students things they will discover later on. Okay. This is the electric field, and you can see. Okay, so it start from potential 400 volt, 300 volt, 200 volt, isn't it? Okay, but let's say this is a negative point charge. Let's say I have a negative point charge. What happened? Electric field is towards. Electric field is. This is a long lesson. Okay, maybe I talk too much. Yeah, too much explanation. Maybe it's unnecessary. Yeah. Maybe my explanation is based on impulse. Okay. You will see something like this, class. If positive charge, you have potential 400, 300, 200. So if negative charge, you will see negative value, negative potential, negative 400, negative 300, negative 200, and the outside, the outermost one is negative 100. Why this one is a positive value? Why this one is a negative value, class? Why? Tell me why? Why this one positive value? Why this one called negative value? Why? What does it mean? Is it mean, 400 watt means 400 watt here, it means potential to the right, potential 400 watt to the right. 300 watt here means 300 joule, 300 watt to the right also. This one to the right also. This one all to the left, to the left. 400 watt to the left, 300 watt to the left. Is the positive negative here means direction, class? Does it mean direction?
Potential energy.
Yes, it's potential energy. This positive negative sign here does not mean direction. Remember, this is a potential equal to KQ over R. This is a scalar quantity. No direction involved. No, it's not about direction. It's not about direction. The positive negative sign here, is all about value. It's not about direction. It's never about direction. Okay, you say positive negative sign is about value. How to understand this, class? How to understand this thing? You say positive negative sign is a value. Okay, very simple. You learn mathematics. Any one of you don't learn mathematics here? Anyone of you don't learn mathematics here? Anyone? No, And all of you learn mathematics, You know the number scale, kan? Number scale, right? Number scale. So which one is bigger among these 5 numbers? Which one is bigger? Which one is smaller value, class? Which one is the biggest, lah? Which one is the smallest, class? Which one is the biggest? Okay, which one is the biggest number? Tell me.
2.
2. Good. 2 is the biggest, largest value. Which one is the lowest one? Biggest, let's say. Or highest lah. Highest. Which one is the lowest value, class?
Negative 2. Negative 2.
This one is the smallest or lowest value, kan? Lowest value, right? Is it mean, positive 2? Positive 2, that means 2 to the right. Is it means 2 to the right? Negative 2 means 2 to the left? Is it mean this way? Is it the negative sign here? It means 2 to the left?
No.
No. So the positive negative sign is never always about direction, isn't it? So it's a joke. I tell me, you tell me. I tell you, you tell me. It's a joke, isn't it? When you say this is about direction. 2 positive 2 means 2 to the right. Negative 2 means 2 to the left. It's a joke, isn't it? Do you see this is a joke? Okay, never mind. Now you see it. Yeah, don't need to emphasize anymore. Okay, so yeah, so positive means highest value, negative means lowest value. So negative can also means about value. It's never always about direction, isn't it, class? It's always about value. So negative 2 is smaller than positive 2. As simple as that. So you tell me. Now you tell me. This is a positive charge. Okay. So all these are potential value, V value. Which one has the highest potential, class? Which one has the highest potential? 400, 300, 200. Which one has the highest potential? Class?
100.
Louder, I cannot hear. It's very, very far away. Yeah, you are in Camp L
400.
and I'm at home, very far away. Yeah. Which one is biggest? 400. That's right. So this one is the highest value. Yeah, highest. Which one is the lowest, class? 200 lah kan?
200.
200. Good. So when far away, it has the lowest potential. Understand? Lowest potential. And nearer to the charge is highest potential. Now, go to this negative point charge. Oh, negative 400. Until negative 100. Is it mean 400 to the left? Definitely not. So now, the other question I want to ask you. Now you know this is about value, right? Value. So among negative 400, negative 300, negative 200, negative 100, which one has the highest potential? Which one has the highest potential? Number scale. Which one has the highest potential? Takkan matematik kamu pun tak tahu. Which one has the highest potential? Highest V.
Negatif 100.
Ya, betul. Negative 100. Highest potential. Bagi negative point charge, potential yang paling tinggi di paling jauh. Tetapi kalau positive charge, potential paling tinggi paling dekat. Yes, that's the case. Betul. Apa yang saya cakap ni, bukan saya cakap. Ini memang konsep. Betul punya. Ini, which one is the lowest potential? Which one is the lowest potential? Cepatlah. Dah 9 ni. Which one is the lowest potential? Which one is the lowest potential? Yeah? Which one has the lowest potential? Okay. Since negative 100 volt is the highest potential, so which one is the lowest potential?
Negative 400.
Negative 400. Yeah, why take so long? I want to sleep, you know. This is negative 400. So this one is lowest potential. Yeah, that's right. Negative 400. So the negative sign here is not about direction. It's about value. It's about value. Like the number scale. The more negative, the smaller the value. The bigger the more positive, the higher the value. The more negative means the lower the value. So this one, the more negative means the lower the potential. See the difference? If positive charge, nearer to the charge is highest potential. But for negative charge, nearer to the charge is lowest potential. Yes. Yes. So now the question, why we say potential, the charge must include negative sign? Yes, you of course, if the charge given like negative 100 coulomb, like you see, like this negative charge, understand? How to get all this value? How to get negative 400, negative 300, negative 200, negative 100? How to get all this value? All because of negative charge, understand? Like let's say negative potential, negative 400. It's all because that's why you must substitute. Let's say if the charge is negative, let's say negative 100 coulomb, you must include the negative sign. That's what it means. Okay, the charge must include negative sign. The charge must include negative sign. Barulah you dapat potential nilai negative 400. Faham tak? Kalau you ignore the negative sign, macam mana you akan dapat potential dan negative value? Betul tak? Betul tak? Betul tak? Thumbs up sudah ya. Sebab saya tutup, saya tak nampak you punya thumbs up. So, saya kena buka baru nampak. So, sorry lah ya. Kalau you thumbs up, saya tak nampak, sorry lah ya. Sebab saya hanya tengok satu screen je, satu monitor je. Saya tak nampak you punya Google Meet tu. Itulah maksud saya. So, kalau charge itu, the question give you is a negative charge. So, the charge you must include negative sign. Barulah you must include this negative sign. Barulah you dapat contoh barulah dapat nilai negatif potential, negatif 400 lah, negatif 200 volt lah. Macam ini nilai ni. Ya, tapi line distance lain dia punya potential kan? Kenapa? Sebab R ni berlainan. Kalau R dia semakin besar, maka potentialnya semakin kecil. Bukan semakin kecil, dia punya nilai semakin kecil. Begitu. Kan? Dia punya nilai dari 400 menjadi 100. Kenapa? Sebab R semakin tinggi, di mana potential, di mana nilai akan dia bahagi dengan nilai lebih besar, divide by a bigger value, so the value becomes smaller. Okay, the value 400 become 100, all because of R value, different R value. Understand? So to get the negative value for potential, the charge itself, you must include the negative sign. If the charge itself is a negative charge, the charge you must include the negative sign. Then only you get a negative potential value. Negative 400, negative 100. Oh, itulah maksud dia. Faham tak? Banyak kan explanation? Terpaksa lah. Yeah? Because if I just blankly tell you, I blankly tell you force, ignore negative sign, force, electric field, ignore, charge negative, ignore. Tapi kalau potential pula kena include negative sign. Okay, for those who just accept, ikut, pengikut, setia, tak ada masalah. Tetapi ada orang yang rebel kan, yang tak faham, dia nak explanation. So hari ni saya explain banyak lah. Ya, explain banyak, bagi sikit contoh lah. Itulah dia. Yeah. So okay, yeah. So I think I teach quite an important concept for today. Terpaksa for potential. So today I only teach a small part only. Just a small part. I'm so sorry lah. Yeah. Just about this definition of potential and why we must include the sign, the negative sign. Just these 2 points only, 2 concepts. Yeah, for 1 hour. So very sorry. Yeah. I have to. Yeah. So okay, so that's all for today. So see you in the next class. Okay. I have to end today's session. Okay, everyone, you understand today's class? You can give a, yeah. So if you don't understand, you can go back to the video, watch the 1 hour video. Okay. So all right. Okay, so okay, see you in the next class. Okay, and good night, everyone.
Thank you, sir.
Thank you,
sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Okay, thank you.